Okay, today I wanted to show you how to process data in Chromeleon. So this is a sequence of injections that I made. Just to give you a little background, the name of the sequence is custom NSO pests and T. So basically, what I did was I took some catchers, extracted T matrix in ethyl acetate cyclohexane, and I spiked it with this vial I found in the fridge. It was named like custom NSO pesticides. So I spiked them in like in 1 ppm concentration, um, and I also made like 10 ppb5 and 1 ppb. And um, so let's process this data. I mean, to process data, to do any data analysis, you would data analysis like peak detection and library searches and reports and stuff like that. You need to go into Studio. So you can go into Studio by clicking on the Studio button, or double clicking on this, or double clicking on any of the injections. So let's do that. So let's double click on this. So as soon as double click, you enter the Chromeleon Studio. So 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 you, so you see the chromatogram over here. So this chromatogram is for this injection, which is named blank. So you click on your injections, and and the appropriate chromatogram shows up on this pane. So you click on any of these, and the chromatogram shows up over here. So 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 as you can see, I mean, this is just a chromatogram, and nothing has been integrated, or like nothing has been done. This is just the raw data. So to start data processing, what you need is a processing method. You could do this in multiple ways. Um, so you can, for example, this pane over here is the processing method pane. So right now, since we don't have any processing method, um, it just gives a template. So basically, choose a processing method template. So since this is MS quantitative, I'll choose this. This is like mass spec data, so I'm choosing MS quantitative template, and just click next. You give a name to the template. So let's say YouTube method. Okay, and then assign the new processing method to. So I'll just assign it to all injections, and then I click finish. So as soon as I click finish, you can see it has integrated all these peaks automatically. So since this is a mass spec data, so what do you need to go to the MS detection tab over here. Okay, so if it was like FID and TCD and all those analog detectors, you would go into this detection. Um, so over here you'll have your MS detection settings. So right now the algorithm which it uses, which it has used for detecting these peaks, is ICIS. So but you can choose different algorithms. For example, you can choose the Cobra, and you can see it has detected the peaks a bit differently. Or you can choose Genesis, and choose it. Just doing something. Okay, there you go. So, it has detected it differently. I generally like ISIS. Um, um, so let me show you another thing. So now in the chromatogram pane, if I go to the layout, so over here, it is showing you the baseline only. So, but suppose I want the delimiters. So, if I click on the delimiters, it will show you, how it has detected the peaks. For example, let me zoom in into this. So yeah, you can see which all peaks it has detected. So it has detected a number of peaks. Okay. Let me go to full scale. You can just double click over here and this small window over here, and it goes back to the original. Anyway, this is quite busy. So let me click off the delimiters. There you go. What else do I need to show you? Okay, so let's see what each of these peaks are. So in a previous video, I've already shown you how to do library search, but we'll try and I'll show you one over here too. So for example, what is this big peak over here? So let me click on this peak, and as soon as I click, the mass spectrum shows over here. So you can right click and just to find in library, and there you have it. Yeah, it's caffeine, and yeah, like tea is supposed to have caffeine. So what else can I show you? Okay, so like I said, I've spiked the T matrix with 1 ppm NSO pesticides, but I don't know what those pesticides are. So good way to find out, I mean, there are a number of ways you can do that. You can keep on clicking on each of these peaks, and then it'll probably, and then you can get an idea what each of these peaks are, and then basically um, if it's a pesticide, then there's a good, if the library hit shows that it is a pesticide, then, and if the mass spectrum matches well, it's a good chance that that's the pesticide that's contained in that mix. So this is the T matrix injection, and this is the pesticide. So obviously you can see, just by clicking back and forth, you can see there are some extra peaks in this 1 ppm NSO injection mix. So let's do this. Let me compare head to head, to make my life easier. So let me overlay the 1 ppm injection with just the T matrix. So you can't see this clearly, but it has overlaid it. So let's do this. Let's make this such that you can see it. So if I do stacked, so this is overlaid. So if I do stacked, so obviously it is stacked one over the other, and then you can see which peaks are missing in the matrix, right? Another thing you can do is you can go to overlaid, to overlay, and then you can have a time offset. So if you do time offset, oh sorry, yeah, if you do time offset, it offsets the time, but I don't want time offset. I want signal offset so that I can look at it more clearly. And there you see, I mean, obviously a few peaks over here are obviously not present in the matrix, right? Some peaks over here too. So let me zoom into this region. Okay, so obviously this peak over here is not present in the matrix. So the matrix is the black line. The blue trace is the one which is spiked. So let me click on this particular peak. Okay, it shows up in the mass spectra over here. So there are two mass spectras. One is for the spiked one, so the 1 ppm NSO, and one is just the T matrix. So let me search the T matrix. Okay, it's cymetrin. That seems like a pesticide. Yeah. Let me click on this one, and I do library search. And this is terbutrin. Okay, that's also seems like a pesticide. So this is one way where you can individually go to those peaks which are missing and find out. Let me zoom back. what are the other ways you can do this? So if you automatically want to show all the what instead of individually doing the this library search, what they call this ad hoc library search, so but it's going to take some time, right, to sort through. So another way is let Chromeleon do it automatically. So let me remove the overlay. So this is the 1 ppm mix. Let me remove this too. And just go to the interactive results over here, and if I go to library search, it should automatically library search all the peaks. Okay, it's showing NA. Okay, I know why. So if you go to the processing method, so sometimes, I mean, there are many panes over here and it can get a bit confusing, but one thing to remember is the pane which is active will be shown by this orange. I don't know if you can see, but there's an orange border, and that shows which is the active pane. For example, if I click on this chromatogram, so this is chromatogram pane, so this is the orange border. Can you see that? And all the necessary buttons, or what they call tools, will be visible. So say I want to do something with the mass spectra, those buttons won't be visible. So the buttons that will be visible on this ribbon bar will be relevant to what you have clicked. So basically, so relevant to which pane you are in. And the pane you are in is shown by this light orange or yellow border line. Okay, so I just wanted to tell you that. Anyways, let's go back to figure out why this is showing NA. So, and I'm pretty sure I know why. So let me go to the processing method and MS library searching. So as you can see, there are no libraries that have been added. So, and since no libraries have been added, it doesn't search. So let me add some libraries. So you click add. So the libraries in general, they're located in this location, C drive, program files x86, and where did it go? Okay, NIST MS search, and these are all the libraries that you have on your computer. So let me do the NIST main library. So this is a very common and popular library, the main library, the NIST main library. I have the NIST 14 edition. If I click OK, so as soon as I click OK, it's trying to find the library matches for all these peaks. So as you can see, there are quite a few peaks, so it's going to take some time. So there you have it. I mean, let me expand this window. Another thing, since you're done with your processing method for now, you can uncheck or unclick this, and that pane will go away. So so you can see, I mean, like, it has library searched all the peaks that it has integrated, all these peaks. So many of these compounds. So this is the library compound. This is the first hit. It gives the match results as well. This is the second hit, the third hit. So it gives you three hits. So you can go through this list and try to see which which of these are pesticides, and that's one way which you can figure out which are the pesticides. For example, they go with the cymetrin that we saw. Another thing is, so if I click on one of these peaks, that the library hit for that peak, it shows as as the highlighted one over here. So for example, I think this is the Symetrin, right? Yeah. So that's the Symetrin. This is the, oops, there's the Terbutrin. So you can do that. So you don't have to individually go right click and find your library. So yeah, just saves you some time, I guess. So okay, let me stop over here, and we'll continue afterwards. Okay.